Let's have a look at question 3. It's practice 8, page 436. A charity organises a soccer game to raise money. There are 15,000 seats in the stadium. From past experience, they know that when the tickets cost $15, they sold 9,500. For every $1 decrease in ticket price, the number of tickets sold increases by 1,000. Well, that makes sense. Cheaper tickets, more people turn up. A. Copy and complete the table. Let's have a look at the table first. Price is here. Decrease in the ticket price, 15 minus 15. That means there is no decrease. That's what that number there is, the decrease. Increase in attendance, well, if the ticket price doesn't change, we're still back at 9,500 people attending. The sales are 9,500 times 15. Okay, there. Now the second one is 14. If the price is 14, it's dropped by 1. Okay, and it said for every $1 decrease in the ticket price, the number have increased by 1,000. So 1,000 times 1 is 1,000. So here's the increase of 1,000. 9,500 plus 1,000. It's gone up by 1,000 because the price has gone down by $1. So now we've got 10,500. The total sales is 10,500 times the price of the ticket, which is 14. There. So all we need to do is fill in all of this. All right, let's do that. Well, we just follow the bit of the pattern here. We've got 15 minus 13 equals 2. And that would be 1,000 times 2 equals 2,000. 9,500 plus 2,000 equals 11,500. And this will be 13 times 11,500. And that equals 149,500. 149,500. Here, same pattern, we've got 15. We take away 12, and that equals 3. It's 1,000 times 3, and that equals 3,000. It's 9,500 plus 3,000. It's the increase, and we're up to 12,500. So that becomes here 12. That's the ticket price, times 12,500, and that equals 150,000. All right, now we've got this next line here. We've got P, and we've got 15 minus P. Okay, so you see what we've done there, 15 minus P. So this would be 1,000 times 15 minus P. The total attendance will be 9,500 plus 1,000 times 15 minus P. And then all of that number here, this increase, that whole thing is multiplied by the ticket price P. We've got P outside of 9,500 plus 1,000 times 15 minus P. So that's filled in. And then 3 is, we'll look at B, 3B. From the last row in the table, find a function. From the last row in the table, find a function for the sales generated in terms of ticket price P. Well, that's that one. So we're going to put S for sales. S equals P times 9,500 plus 1,000 times 15 minus P. Okay, let's have a look at C. Write an equation to find the ticket price that would be so expensive that nobody would buy a ticket. Solve it using the most efficient method. Well, what they're saying here is that if no one buys a ticket, the attendance would be 0. Now, all of this is decreasing ticket prices and increasing the attendance. Well, in question C, they're asking us to solve it for the most expensive ticket, not the cheapest, so we're going to be heading the other way. So instead of taking off $1, we're going to add on $1, okay? If we add on $1, we want to add on $1. Every dollar we add is going to be 1,000 people less. So we add on $1, that's 8,000. So what we want is this value of that to equal 0. When that 9,500 becomes 0, if we just solve for that, we should find an answer here. So why don't we do that? C. 9,500 plus 1,000 times 15 minus p equals 0. Got 9,500 plus 15,000 minus 1,000 p equals 0. And divide through by 1,000. We've got 9.5 plus 15 minus p equals 0. And we've got p equals 24.5, and that's dollars. So I should put the circle there too. Okay. Let's have a look at D. Determine the ticket price that would maximize sales. So when it says maximize, we're expecting a quadratic that's an upside down parabola with a negative A coefficient. How many tickets would you sell at that price? Okay, so let's have a look at that, shall we? We're going to expand this to turn it into a quadratic in the form that we know. So for D, we've got S equals P outside of 9,500 plus 15,000 minus 1,000 p. Let's resolve what's in here. We've got 9,500 plus 15,000, that's 24,500 minus 1,000 p. Okay, look, why don't we leave it? Well, we divide through it by 1,000, we'll get rid of that. So we've now got dividing through by 1,000. Now we're going to equate that to 0. Let's equate that to 0 first. Now we can make sense of this. Let's divide by 1,000. So we've got 0 equals p outside of 24.5 minus p. Okay, so now we know the roots. The roots are p equals 0 and 24.5. So the vertex lies between that. So that means the maximum occurs at 12.25. Okay, so we've got 12.25, that's dollars. Okay, so we know 12.25. Now, normally when you do quadratics, you would then put that back in and find the value for the total sales. But the question was, how many tickets would you sell? That's the tickets. So let's put that p value of 12.25 directly into this. Okay. So total attendance, and they'll call that tickets, total, or attendance we'll call it, total attendance equals, okay, so the total attendance is 9,500 plus 1,000 times 15 minus p, which is 9,500 plus 1,000. 15 minus 12.25 is 2.75. So that equals, the answer is 12,250. Okay. Now that answer represents the total attendance. Okay, so that's people. Okay. Let's have a look at E. We'll do E over here. Okay. E. It says, determine the ticket price needed to fill all 15,000 seats. Well, to fill 15,000 seats, remember that's the attendance. We're back to this one. We're not using the quadratic. We're just using this one. So we're going to use this equation here and equate that to 15,000 and find the value of P. Let's do that. Okay, let's have a look at this. So we've got 15,000 equals 9,500 plus 1,000, 15 minus P. So that's going to be 15,000 minus 9,500 divided by 1,000 equals 15 minus P. So we'll get rid of these. And we've got 55 over 10 equals 15 minus P. P equals 15 minus 5.5. So P equals minus 5.5 will be $9.50. $9.50, yeah, $9.50. Okay.